All right, welcome to part 2 of this electrostatics charges video. It's really charges. And what we're going to look at in this part is electrostatic forces. So what happens once once an object has a charge, what's going on? Well, there's forces that are attractive and repulsive. And so watch this little video that has some really cool demonstrations showing these forces. All right, did you notice that when you had like charges, in other words, when you rubbed both rods were black that you rubbed, or both rods were clear that you rubbed, you had repulsive forces, creating that torque, causing that to spin. And then conversely, when you had opposite charges, one black rod, one clear rod, and you charged them, you had attractive forces. That's because the net charge on, say, the black rods when they're rubbed is either positive or negative, and when you do the opposite one is either positive or negative. We'll do a cool lab that you'll see that will show that. Another way, that was charging by friction. Another way to charge is by what's called induction. Now, if we rub the balloon over here and get all of our charges from that sweater onto the balloon, as many as we can, those charges actually don't want to be near each other. Negatives don't like each other, positives don't like each other. They want to be matched up, positive to negative. So if I bring this balloon now close to the wall, which has a balance of charges, positives and negatives, the negatives on the balloon push the negatives in the wall away. And what actually happens is now you've got charging by induction. No charges have moved, but the charges in the balloon have created a force on the charges in the wall. In this case, negative on the balloon, negative on the wall, pushed away those charges, so created an area that is positively charged on the wall. And that's why the balloon will stick there, due to that induced charge. If I bring it over to the sweater, of course it sticks also, but the wall, while the net charge on the wall is still zero, in areas it is positively charged and negatively charged. All right, a little bit. The last thing I wanted to talk about is the actual value of our electrostatic force. So here's our equation sheet, and if we go down, we're done with the first 2 pages. We're here on page 3, and in this little section here is about charges. So we can zoom in a little bit on that, and you can notice that the force, the electrostatic force, looks a lot like gravity. It is set up the same way. It's 2 physical qualities. Radius squared, it's an inverse square law, and it has this universal constant, in this case called Coulomb's constant. So very similar to gravity. Here's a very big difference though. If I go down to my sheet, about constants, and I go in and zoom in there, and I go down to Coulomb's constant, it has a value of basically 9 times 10 to the ninth, where gravity, remember, had about 7 times 10 to the negative 11th. Made gravity very small, makes these electrostatic forces very large. Alright, so I will see you in class, and have a good day.